Ladies and gentlemen, thank you very much for giving me voice. Today, about talking about solutions and this is how solution will be solved. And solutions, how about solubility and percentage and moles concentration. Solubility is the amount of substance that solve in a given solvent in temperature and pressure. The speed and velocity of solving, it depends of stirring velocity and the degree of the solved matter, solved matter. The solubility is for solving is to disbalance the intermolecular forces in between solvents and solute with introduction of proper entropy, for example by heating mixing. The energetic change can be measured by observing change of temperature or pressure. The mincing and making the smaller part of solute increase the area of interaction between salt and solvent. The intramolecular forces from labor from the strongest to the weakest. The stronger is forces ion electrostatic, which has electronegativity between themselves above 1/7, covalent binding from 0.4 to 1/7, include a covalent bonding as special hydrogen bonding, which is the special because hydrogen is very active one ion with positive charge, and is for example is always interparticipated between the atom of molecules having usually negative binding of hydrogen. If it occurs in the one molecule, it is also expected in the as weak binding, but in different two molecules, it becoming more for strongest, making binding one of somehow more molecules. There are exchange dipole, which can be having stable dipole moments with the over charge of negative ions, and in other the lack, which interact with themselves like ions, but these interchanges are weaker because they are particular electric charge, and the magnifying of charges is mostly the distraction, not attraction. The van der Waals forces are between dipole and induced molecule. These molecules don't have stable dipole moment and can be initiated by the particle with stable dipole and can occur in electron orbitals. The van der Waals forces are with correlation of movement of electrons walking between electrons. This is has to be in calculation, but in most possible. If not in particle state, it don't have. The dispersion of also dispersion of London. This intermolecular forces always occurs not independently if particles have stable dipole moment. The present is in the moment that the diversification of charge occur about the nucleus is asymmetric to the nucleus and outside. In the most case, it has as intramolecular forces sometimes stronger than dipole and dipole induced. So van der Waals equation. So these are 5, and the ionic lattice has the strongest force. Between 250 and 4,000 kilocalories joules, or in kilojoule per mole, 1,100 to 20,000. In case of covalent bonding, these are from 30 to 260, and in case of enriched states to 130 to 1,000 100 kilojoule per mole. In case of hydrogen bonding, the dissociation is just 1 to 10 and 4 to 50. But in case of water, it's particularly strong, 21 kilojoule per mole. So in case of dipole, it is only 0.5. The dispersion forces of London it is 4 to 6, with measured mostly on energy of vaporizing of hydrocarbons. The key element of the solution is ionic number, which is solvent determined have it as polar or non-polar, and these are kinds of solvents, polar or non-polar. It's uh, uh, connections, electronegativity, solving polar compound between 0.5 to 2 are polar. In case of above 2, a special polar which is called ionic. Polar and polar have big electronegativity difference, which solves polar compounds. So this is show how this energy, in case of water, which is very special kind, here is oxygen, and due to the movement of this hydrogen, it occurs differently and make this strong affiliation and behavior that is can in case of hydrogen water alone is calm. However, it can move in itself, and we see in few examples how it works in acidic conditions. The water is with electronegativity 1.5 is very strong polar, while acetone is popular because it's popular for organic solvent. Non-polar solvents popular are hexane, benzene, toluene, diethyl ether, chloroform, octane, tetrahydroform, or metal, and we see that very small dipole moment. So this is the density, the temperature of boiling given in case of protic, which are small, has acetone, acetonitrile, dimethyl and dimethylosulfonide. In case of acid, the propellant, which are strong, is the strongest water. It's acidic and butanol is a propanol and propanol, ethanol, methanol, as formic acid and water. The impolar is for good for solving alkanes, aldehydes, ketone, and esters in extraction of benzene, for example, parabens and sulfides as natural products. So this this and acid and polar are good for solving alcohols, salts, hydroxides, and acids. The state of solvent is also very important because temperature, we see the temperature and getting the supercritical, this is supercritical fluid, is up for the critical state. This occurs can be both in stable, fluid, and gases. In case of water, the specific stable point that between the division of state between water and fluid and ice, it's going to the left, while in carbon dioxide to the right. This shows the specific properties of waters. That shows that during making the frozen is under the surface, not the oil. So does the typical. However, we can see that triple state in carbon dioxide is much lower than in water. Specific because can extract and without low loss. Sodium and chloride here how looks solving. In case of acid, the chloride from acid compound, chloride acid, goes to the hydrogen. And this is small unstable bonding. In case of many glucose, if occurs acids, for example, fluoric acid, which is dangerous, it occurs that binds then hydrogen affected to the hydrogen fluoride, then affects the water molecules, making that such action. This shows that there are some different kinds of solutions: saturated, unsaturated, saturated, and supersaturated. Unsaturated with the below the Sargodha curve, saturated in the equal Sargodha curve, and supersaturated above this curve. This shows that some while there can be solution is written as percentage concentration, which shows this difference of solid to solvent in percentage, or in molar if we have molar per volume. This is all what I wanted to say for today. Thank you very much for listening to me.